All right, so when we're graphing quadratic functions in the intercept factored form, we run into a formula that we haven't seen before, and it's y equals a times x minus p times x minus q. And in this formula, p and q are your x-intercepts. So just like h and k were your vertex, your p and q are the x-intercepts. And there's some things we need to kind of look at, and there's some steps on how to actually graph this. So the first thing and the easiest thing is to actually plot the x-intercepts. Once you see that, just like we'd plot the vertex, this is plot the x-intercepts. And so once we actually plot the x-intercepts, the second thing is to figure out the center of the your quadratic equation, which is AOS. So it's figure out the center, or, axis of symmetry. Figure out center, or, axis of symmetry. We want to be able to find where our graph actually is, and that's going to be right in between, right, the x-intercept, so it's the distance. And number 3, okay, that x value, okay, the value of what we find in the middle, so the x value of the axis of symmetry, that x value, right, that x value is the value of the vertex, Just like, remember when it's what is the axis of symmetry once we have our vertex point, right, our HK, and our H is our axis of symmetry. That's the same thing here. So once we find that, we can find y, because then you're going to use, right, the x value, and you're going to plug in to find y. Once you find the x, just plug in where all your x's are, and you get the y value. And that is your vertex. So that is your vertex. And we're going to do a couple of these. And your y-intercept, if you ever want to find your y-intercept during this, remember, your y-intercept, you're just going to equal all the x's to 0. So set x equal to 0, and you'll be able to solve for y. Now, let's do a couple examples of one of these, and I just want to rewrite the formula right over, or right under actually, the equation we have here. So it's x minus p and then x minus q. All right, so now we notice that if we're looking at our equation, okay, p and q are going to be the opposite. Just like it would be minus h, p and q are going to be the opposite of what's there. So right now it's saying a plus 1. Well, I know it's an x minus p, so it's going to be the opposite. So my y-intercept is going to be a negative 1, just like it's x minus h kind of concept. And then it's x minus 5, so my other intercept is going to be 5. Now, my slope, is it happy-go-lucky or negative Nelly? Well, it's a negative Nelly, so I know it's pointing down, and I know my slope is a negative 1. All right, so from here, I kind of have to find the middle, right? I kind of have to find the middle, and one of that step is to be able to solve for x. How you solve for x is you're going to want to find the middle of your, between your 2 points, and that actually is 2, right? So once I find that, I'm actually going to plug that 2 in for x, and that's because I want to find my y value, right? This is my axis of symmetry, so I know for a fact that in my vertex, right, my value is going to be 2. Well, now I need to find my y value. So to be able to find my y value, I'm going to plug in 2 wherever I see that x. So I'm going to get a negative on the outside. I'll have a negative, and then 2 plus 1 times 2 minus 5. And then let's just simplify. 2 plus 1 is 3, and then 2 minus 5 is negative 3. So negative 3 times 3 is a negative 9. So I have negative 9, and I have a negative on the outside, and two negatives make a positive. So my y value on my vertex is 9. All right, so my whole entire vertex is 2, 9, and you know, I really don't have all that crazy amount of room. I'm assuming like my point is there's 6, maybe here's 7, here's 8, and here's 9. So I'm going to put a 9 right there, try and make it nice and big. And then my slope is negative 1, right? So that means I'm going to go down 1 over 1. So here are my next points, down 1 over 1. And then from my vertex, I'll go down 4 and then over 2. So here's my 4 over 2. And then it should be going down 9 over 3. And here is my graph. So all we are doing is we're just finding P and Q and then solving for our vertex. And let's just do one more. Remember, P and Q are opposite. So my P equals negative 1, my Q equals positive 3. So at negative 1 and positive 3, well, what's the middle of that? It's going to be 1. So I know my axis of symmetry is 1, and with that 1, I know that's my x value of my vertex, meaning I'm just going to fill it in everywhere I see an x. So to find my y, so I get y equals 1 plus 1 and then 1 minus 3. Well, let's simplify that. That is 2 times 1 minus 3 is negative 2, and that equals negative 4. So my vertex is 1, negative 4, and so at 1, negative 4, here's my vertex point. And now I'm looking at my slope, and there is a secret little 1 right there. So I'm going to go up 1 over 1, and then the next point should be up 4 over 2, and it is. And here then is my graph. That's all we're doing for these. That's it. So what if my slope isn't 1 or 2 or a really nice number, something like a fraction? Well, I mean, that's easy enough to do. First, I just need to find my P and Q. And so P equals a 5 and Q equals a 3. So my x-intercepts are at 5, or no, Q equals a negative 3. What am I doing? Equals 5 and negative 3, okay? And the middle of that is actually 1. So I know my vertex, my first x value is going to be 1, and that's where I'm going to plug into my x's over here. So I'm going to fill in, I'm going to have negative 1/2 times 1 minus 5 times 1 plus 3. That equals negative 1/2. That's 1/5. Times negative 1/2 times 1 minus 5 is negative 4. And then 1 plus 3 is 4. So I have negative 1/2 times negative 16, and negative 1/2 times negative 16 is a positive 8. So I know my vertex is 1, 8, and again, that's off my graph. I really need to draw my graphs better. And so maybe that's 2 up, so that's about right there. I'm just going to guesstimate. Now I'm looking at my slope, and it's 1/2, meaning I'm only going a half down compared to what I originally would go. And I originally would go 1 down over 1, but now I'm just going down a half over 1. So it's probably right there, and now on the other side a half over 1. And then instead of going down 4, I'm going down 2 over 1. So I'm going to go down from the vertex, I'm going to go 1, 2, and then, over 1, over 2. So 1, 2, and then over 2. So here are my points. And then instead of going down 9 over 3, I'm going down 4.5. So we go 1, 2. So here's 1, here's 2, 3, 4.5 is right there, and I'm going over 3. So here are my 3's, and then the next one should line up to my y and x axis. So here's my graph actually right here. And so the only thing that's changed is the slope, and you're still plugging in all your x and y intercepts. Your axis of symmetry can still be found just the same way. The only difference is the slope. Lastly, real quick, we're looking at all this and being able to graph it, but let's just go backwards and write the equation. The way I write the equation is in intercept form, specifically in x-intercepts. You find your x-intercepts, right? You find your x-intercepts. So if your vertex is at -1, -2. Okay, and if I'm looking at my slope's going up 2 over 1, so I know my slope is a +2. And now we're just going to be using, our equation, y equals a times x minus p times x minus q. All right, so we're just going to fill out our p and q. Our p is -2, okay, our q is 0. So we're going to have a, which is 2 times x minus p is +2, and then x minus 0 is just x minus 0, or you could have just left that as x. All right, just like we'll do one more. Just like the next one, you're just going to find your p and q. So I have p is -6 and q is -2, and we're just going to fill it in. Well, first I have to find my slope too. And my slope is 1 over 1, so my slope is actually 1. So I'm going to have y equals, all right, 1, and you can leave it out. So I'll probably just leave it out, right? It's secretly there. And then it's going to be x minus q, which is a +6, or I'm sorry, x minus p, and then it's going to be x minus q, which is a -2, so it's going to be the opposite, which is a +2. And that's just writing your formula in intercept form.